Good morning, everyone. My name is Ravi and today I'm honored to present my master's thesis titled Improving Data Retrieval in RAG Models with Ontology Augment Semantic Based Understanding. This research was conducted as a part of my master's program in the Department of Computer Science and Information Engineering at Asia University. My work was guided and supervised by the esteemed Dr. Ching Shun HSU. Through this thesis, I aim to explore innovative ways to enhance retrieval augment generation models using domain-specific ontologies to improve semantic understanding and retrieval performance. So let's dive into the details of the study. Here the outline will be the introduction, related work, methodology, evaluation, results, and conclusion. In the introduction section, I have prescribed about LLM struggles with hallucinations, and which means LLMs are able to provide the inaccurate answers and outdated answers, and lack of interpretability, which means they are unable to understand the complete domain meaning of the data and hindering their reliability, which means it's where it is retrieving the data. Is it from it does not provide the data sources where it is retrieved from. For that problem, there is the existing solution called RAG method, retrieval augment generation. Now at present RAG models face limitations in retrieval, computational cost, and cost bias. And the main point I have pointed out one thing: the RAG models are unable to provide the domain specific knowledge. So here I have developed an ontology augment RAG model to improve the RAG model performance by integrating the ontology structured data. The ontology, which will represent the structured relationships and entities in a specific domain or in any of the field, and it will provide more accurate, explainable, and domain specific outputs. The ORAG enables the efficient retrieval, and researchers are able to generate the answers, questions, and generate the ideas and conduct the literature review. By that approach, most of them, it will lead to the reducing the brainstorming period of developing any of the research products. Here I have described about, here we can see the data sets which I crafted for the specific use case: transistor, applied materials, crystallography, semiconductor chip, elementary multi-perspective material, ontology, AI chip development, memory technology. In this section, ontology, which is like enriched with semantic information, structured and organized, which means the data which is crafted in the structured method, which will guide to retrieve the data from the unstructured data. So it was my basic idea. Strategy: data quality and consistency. The ontology is converted into the knowledge graph, which is easy to access and understandable by the LLMs, which is semantic relationships, structured knowledge representation, domain specific knowledge we can represent. ORAG: by the ORAG approach, by augmenting the RAG, the data will be augmenting the RAG with ontology. It will leads to the efficient retrieval, accuracy, completeness, performance, semantic reasoning, data quality, coherent responses, and communication, complete answering. Here I have described the existing solutions like NaviRag, Advanced RAG, and our approach. Let's consider a question: what is the recent chip developed by the NVIDIA? When we ask this question to the NaviRag, which means what we given the data, based on that only it will give the data. It will not able to acquire data from the data sources or through the APIs or anything else. So it might return a document mentioning both transistor integrated circuits, but without explaining their relationship. When goes to the advanced RAG, could find the data sources that describe how transistors are used to build integrated circuits, which means it will clarify how it is developed, and it gives a specific explanation about each of the element or any product asked by the user. when it comes to our approach, this would leverage this semiconductor ontology, which I crafted the data sets based on the recent chip developments, AI based anything else. So ontology to ensure the retrieved information consistent with defined relationships here between the how transistor and integrated circuit and semiconductor and other related concepts in the semiconductor domain are related. By using the ontology argument track, it adds a layer of structured knowledge and the semantic representation of the retrieval process, and it will become a more powerful choice for domains where accuracy and consistency are paramount. When it comes to the contributions, as we know that I have introduced the ORAC hybrid model and enhanced efficient and accurate model, which was discussed in the slide 16, domain specific expertise with dynamic responses, and identified the limitations in BM25 algorithm, which is able to retrieve the data effectively, and integrated my approach semantic and keyword based retrieval approach, which is an hybrid algorithm, improved novelty in idea generation and handling complex and ambitious inquiries. So this is my related work based on these previous existing solutions. I have overcome all the sources, all these limitations. We can see our RAG models, the data format, the injected format will be the unstructured data approach, keyword based retrieval, the limitations, retrieval bias, factor verification, potential inefficiency, limited reasoning, and contextual understanding. When it comes to the advanced RAG, unstructured data, keyword based retrieval, pre-retrieval, and post-retrieval, which means re-ranking. If it is suits for, if it gives multiple documents, if a user asks about the particular questions, if it is not found out in the one document, it will re-rank. It will check for further and further until it finds the exact answer. When it comes to the graph RAG, it's a structured data, semantic retrieval, and keyword retrieval. Limited domain coverage, inability to update the knowledge. I have encountered these limitations in this. So later I have structured data. I have the structured data in this approach. Structured data will guide the unstructured structured data is used to guide to retrieve the unstructured data. Then based on semantic, keyword based, and re-ranking approaches. By our approach, improved deep semantic retrieval accuracy, reduced the computational cost, enhancing explainability and trustworthiness. Here we go. In the methodology, I have crafted the knowledge base for semiconductor research using the specified ontologies and concepts which were linked to the research papers from ARXV. By that approach, if a user asks any questions based on that, the model is able to retrieve the data from the ARXV API by using its specific API key. Dataset for creation built an 150 semiconductor related questions and answers for testing. The main aim of the project here, I have the hybrid system, which is called ORAC system, process the user questions through NLP by using the techniques like tokenization, stemming, lemmatization, parts of space tagging, named entity recognition. Those sections are described. Those are explained in the further slides. Sorry. The ontology the ontology is converted into the Neo4j knowledge graph based on the concepts it searches for the graph which are relevant to the research papers using ARXV API and combines the information to generate comprehensive idea on answering using powerful language model called GPT 3.5 Turbo. And finally, the evaluation is done by testing the ORAG using the benchmark datasets which I crafted before and we discussed to assess the responses, accuracy, relevancy, and trustworthiness. And finally, analysis compared ORAG to the existing solutions, highlighting the benefits of using the domain-specific ontologies. This was the proposed ORAG architecture. Here, when the user submits his inquiry, it will be processed by using NLP approach. Then based on this user inquiry, the data will be from the ontology data sets, it will be loaded to the retrieved by using the BM25 ranking algorithm. And then these graphs, here we have performed the graph search by using the data will be in this ontology to, we converted ontology to knowledge graph, which is the structured data. Here we have the data will be in the format of semantic structure, which means each entity relationships, how they are related. So these will guide the vector DB to retrieve the related concepts from the ARXY research data from the ARX IPE, which will plays a crucial role in retrieving the data. Finally, these sources are combined here, and the context is passed to the LLM. Then it is gone to the GPT 3.4, and it is prompted for idea generation. Here I have, as I said, NLP pipeline for user inquiry processing. The first step when user submits is inquiry input, user input. It will text processing process will be done. Here the first step was tokenization, the process of making the sentence into the chunks, which means each word, subwords removal, which means eliminates the adjectives, which are unnecessary words, and then performing stemming, which is used for making the word to its native part, which means run, the basic word, in order to eliminate the confusion or anything misunderstanding to the model. Lemmatization converts words to their basic format. And speech of parts of speech tagging, assigns grammatical, it is used for identifying the what is the recent chip developed by NVIDIA, previously was described. In that it is used by this approach, we can identify the noun and verb towards the easy understanding to the model. Named entity recognition, which is used for categorizing the significant concepts of how material is a device and how the process and everything. When comes to after these sections done, the data will be gone to the each entity and concepts will go to the here handling variation method is used, which means if the user inquiry input is matched, it will goes to the create embeddings and search for related data source. Otherwise it will iterate to the next again to check for is it suitable or not. Here I have described about how ontologic knowledge graph with the data will be retrieved. For example, how the ontology format is this. We can see if we user ask about what is a transistor and how it is made of and how much bandgap it has. So here, based on that, transistor is a device and it is made up of gallium arsenide, and then it has a band gap and is a property, what is that? It's a property. So based on that question, the retrieval process is able to search for the research article which was related to these concepts and entities. By that approach, the retrieved data is given to the GPT 3.5. It is able to generate the output as we prompted for idea generation. The tools and frameworks used in this architecture. Basically, I have described made it into the three sections. One was the data layer, retriever layer, and third one was generation layer. Here we see the data sources are ontology and the RxV API for research papers. When the user submits input to inquiry, the data will be processed by using NLP tool, and data retrieval is done by BM25 algorithm, and later this will be performed the semantic understanding for graph database, which is we described ontology knowledge graph, which is we have used the graph database, and keyword retrieval, which is used for APA research papers, ARXV APA. These sources are and these are connected through the line chain, which is able to provide the chains to loading and indexing parts text to cipher, which means when the user submits any inquiry, it will convert it to the SQL automatically. By that approach, no need of deep knowledge of SQL. So vector DB, graph DB, we know, as we all know, that vector database, which is used for unstructured data, and graph DB, which is structured data. Now OP embeddings, which is used for embedding each of the sentences. Open API for accessing the GPT 3.5. Here I have explained about keyword search, BM25, and semantic search, finding in best matches. Here, what is the recent chip developed by? Based on the keyword search, it will find the documents which containing a latest chip, NVIDIA, and the release. Basically, it will only point out the words. By using the BM25 algorithm, it will ranks the documents which are uniquely relevant keywords, and it gives the more weights which are suitable for. Based on that, it will retrieve the data. And semantic search, this is the crucial part in my project, I can say, because it understands the meanings of latest chip and retrieves the documents that contains NVIDIA, which is the recent chip developed by the GPUs, advancements in GPUs, even if they don't use those exact keywords by the user. Here we go. In this hybrid search algorithm combining BM25 and semantic search, this is which I crafted an algorithm for effective and efficient retrieval of the data. When the user search inquiry, the documents are listed to search. Then sorted list of these documents are identified, BM25 score and semantic similarity. Based on that BM25 scores, the document and each inquiry embedded. These documents are embedded. The query and document are embedded initially to understand by the model. Finally, these codes are calculated, and finally those are sorted. Here I have given the scoring 0.8 for BM25, which is an keyword based retrieval, 0.25 for semantic. Here I have considered 0.8 because of most of the available data is in the format of unstructured data. So if we add 0.25, it will adds the relationship between each of this data. This is an idea generation algorithm which I implemented in my project. When the domain specific research idea generation here generates research ideas based on the ontologic knowledge graph, research papers, and those data given to the LLM, then it generates a number of ideas. Here I have defaulted for 3 top ideas. The concept, extract key concepts, relevant nodes, find relevant nodes in the knowledge graph, which are like concepts, related papers, get related research papers and their relevant nodes. Based on the relevant nodes, it will retrieve the data and then generate the ideas. I have given the number of ideas as 3, and then given the prompted here the concepts and related papers. Based on the generate idea with LLM, which is prompted for generating the novel idea generation. Then it generates the ideas, it will add, and then I have ended the procedure. The main crucial part is going to be discussed here, the evaluation of the matrices, the evaluation of my approach. Evaluation of my RAG approach is benchmark on the specific domain datasets which we crafted. The main retrieval matrices are context retrieval, which discuss about the relevant information from the sources which were included in the information or not. When goes to the context precision, how much of the information is relevant in the responses and accurate based on the sources. How much data is retrieved from the sources and how it is related and how accurate it is matching with the inquiry. And comes to the answer relevancy, evaluates overall accuracy and correctness and generated responses about the query, measures how accurately the response reflects the information and in the document. Evaluation of ORAC will be done by specific benchmark data as we discussed. RAGAS, here we need to describe mainly RAGAS retrieval augment generation assessment is a framework that provides the matrices that is used to calculate the data generated by the LLM and the performance of the RAG system using the matrices both for retrieval. This is for retrieval and generator matrices. Here we can see that this is the brief evaluation and the results. Here we have described comparison of RAG approaches with ontology augment RAG by using the RAGAS framework. Here we can see advanced RAG, Navi RAG, and our approach OA RAG. In faithfulness, we can observe that in all the approaches, in all the existing solutions, our approach is giving the most faithful answers. And when it comes to the context recall, in this also our system is performing the more bringing the high values, and context precision also it's performing more than around very good performance we can observe here. And answer relevancy, here we can see that we can observe that the improvement is very less. Here we can work on further. The proposed RAG outperforms advanced all the RAGs, which means the existing solutions. The highest score of ORAG 79.0 for faithfulness, while its answer relevance is 0.578. Evaluation of retrieval approaches. Here we can see the three algorithms I have evaluated. First, BM25 algorithm, semantic search algorithm, and combined approach, which is our hybrid approach, BM25 plus semantic search. We can observe here BM25 is performing around, it's giving the value of 0.8 around. When it comes to the semantic search, it's around 0.86. When it goes to the combined approach, which I introduced, which is an engineered solution in this approach, it's performing over best all algorithms. Here we can see this is the downstream of all the approaches. All the algorithms are performing well in that approach, but when it comes to the context recall, which means remembering of the data and what is the data coming from the sources, it's performing all the algorithms are performing at low rate. Here for further we can concentrate on this. Finally, I have evaluated the latency and cost effectiveness trade-off in such algorithms in three approaches. We can see that the most combined like BM25, semantic search, and combined approach. In latency comparison, which is performing lower is better. The BM25 is performing the best. When it comes to the cost effectiveness, the combined approach, which means BM25 and semantic search, which is performing my approach, is performing the more reliable and accurate. Here the data is coming more well, so it is taking much more time. When combined with these two sources, the data is coming more accurate when compared to semantic search and BM25. So it's also an important thing here we can notify it. In this slide, I have prescribed about the ground truth generation of the existing solutions with my developed hybrid ORAG for idea generation. Here I have taken the two examples of what I have given as input to the our rack system through the user inquiry, through my inquiries. What are the benefits of using 2D materials like graphene in semiconductor material? Here we can see that Navi rack, which is giving the 2D materials like graphene, offers enhanced polarization, non-polarity, precise excitation, control through doping potential. Just an basic explanation has been given. When goes to the advanced rack, we can see 2D materials like graphene offers, we can see here benefits offering in semiconductor due to their high surface to the volume ratio, durable properties. It has given the exact and clear benefits of using 2D materials in graphene. When goes to the hybrid rack system, it explains about the graphene as a tunnel barrier. TFT improves the device performance. It prescribes about the how each concept and entity empowers the benefits, enables low power electronics, and opens the door for advanced transistors design. And also 2D material, integrated 2D materials in flexible substrates allows for bendable, stretchable. This is the physical properties here, material properties is given. Here creates an van der Waals heterogeneous, and the structure format here it is as given, and where it will be the based on the properties it will be used for photo detectors, photoelectric devices, and optoelectronics. When goes to the second question, what is the role of transistors in electronics? Here we can see that transistor is a semiconductor device used for blah blah, just on basic definition. The role of transistor in electronics is to amplify switches electronic signals. It gives a clear and concise answer for that. When goes to the our approach and my approach, quantum dot transistors. Quantum dot transistors use nanoscale semiconductor particles to improve the speed, power, efficiency, and miniature in electronics. 2D dimensional materials for transistors, graphene and 2D materials offers high performance for transistors due to their exceptional electrical properties. And third question, organic transistors. It gives the all what are the available trending approaches are in the market. Based on that, it gives the generates the ideas for the user. Finally, the conclusion section. In this section, I have addressed about the limitations of current rack models and evaluated the improved retrieval, context awareness, and knowledge integration with ontology augment rack system. And ORAC facilitates the idea generation and research assistance for semiconductor innovations, as we discussed in the previous slide. Integrated language models, knowledge bases, and ontologies can revolutionize the semiconductor R&D department. The key point here. ORAC leads to the more accurate, efficient, transparent, and trustworthy RAG models for the semiconductor, for not only the specific semiconductors, it also every and domain specific fields which we promoted for the specific field. Here I have taken the semiconductor industry because of I have a strong foundation in the electronics and communication engineering in my diploma and the bachelor's, total 6 years of studies, and I also did the multiple projects on that. So I have chosen semiconductor industry. So hybrid rack shows the promise for idea generation, but requires rigorous ground truth evaluation, ongoing research for accuracy, robustness, and fairness. And thank you very much for this giving this opportunity to discuss about my research project. It's been a very tremendous support from the professor and my university Asia. Thank you very much.